How we do this is what we want to do is calculate the p-value, and it's just step number 4. And this is what we're talking about. This particular issue is called the difference of two means. Now, there are about 6 different techniques that you're going to need to know, and one of them is difference of two means. I like this one to teach with because it is intuitively understandable what you're trying to do. Is that we have the data for the male students, we have the data for the female students, and we know that the data will be different, and some of that will be due to sampling error, simply because of the people we ask. We haven't asked the entire population of students in New Zealand, we only asked this class. And from them, we may or may not get an totally accurate picture. So that's one of the reasons. There is sampling error because we've taken a sample. There is natural variation because people give different texts. And in fact, if you watch the video, it talks about this. So how we go about it, and there's a second one called differences between means in Excel that shows step by step. So basically you get your data into 2 columns and you use this 2 sample assuming equal variances. Okay, now Excel also has 2 sample, assuming unequal variances, but in this course we will just always assume that our variances are equal. If you go on to do high-level stats, you'll learn about how to test whether they are or they aren't, but it often doesn't make any difference, so we're just going to assume that they're equal. Okay, then we get this dialog box here, and so we put our variable 1 range, that's D1 down to D134, and then we go down, E1 to E126. Notice that those 2 numbers are different. The columns are not the same length. That is because we have a different number of male students and female students who answered the question. Now, later today, we're going to be doing difference of two means paired. When data is paired, they will always have the same length columns, and I'll explain why then. So if you get different numbers there, that's fine in difference of two means. Now there's this thing here that says labels, and what that means is that we have included D1 in the range of data. If you don't tick the labels, it will tell you that your data's funny in some way. If you leave out the labels and you tell it has got labels, then it will remove the first lot of data and call the first column 0 and 0. So that's not going to work either. So you need to make sure you include the labels and tick labels. And then you tell it where the output range is, which in this case is going to be in G1. Okay, so this is what comes out. And so we've got our mean for the females and the males. And look, we've got 37.2 and 36.16. That's not very different. I was surprised. And our variance, if we look at our variance is the square of the standard deviation. So 1400 and 1400, they're both about equally spread. But the thing we're interested in are the p-values, these two things here. So we want to know what is the probability that this number here, which this computer has worked out for us, is less than a certain point that we're comparing it with. In fact, now what's the probability of getting that value if the null hypothesis is true? Okay, so we're saying if the male and the female students actually do text the same, what's the chance of getting this? Well, the answer is 0.81, and that's a pretty high probability. What was our cutoff? Do you remember? 0.05. The level of significance is the cutoff point. And so this value here, and by the way, remember we decided it was 2 tails, and that's why we're looking at this one. If we'd done 1 tail, then we would look at that one. So you need to make sure, because if you put the wrong one down, you get it wrong.